is the tree searching, meaning that if we want to perform the task, we will go through the tree here, visit one by one, and we see which one we will go through first. Now there is an order for this one. We have three methods. The first one we call it as the pre-order search. And when we visit the branches, for the pre-order search, we will start to visit the root. First is the root first. And then after the root, we will go to the left subtree. Then only go to the right subtree. Meaning that the sequence to visit the label of the tree will always like this: root, left, right. And this will be the repeating process until the end of the tree. So it will always repeat the same thing. So the algorithm is like this. Okay, we will look at the example. Let's say you have binary tree like this. And if we want to visit, follow the pre-order search, so we will visit the root first. So the root now is A. After the root, we will go to the left subtree, which is at the left hand side here. This is the left subtree, right? And we will start again with the root. What is the root of the left subtree?
B.
B. Have you learned this before?
No.
Not yet. Have you taken your data structure and algorithm? Not yet. This time? Oh, okay. Then I think they have one part is like this one. So now you learn, then you easier already. So the root is B, and then after that you will go to the left hand side of your B. What is the root here?
D.
D. Now, after the D, you will go to the left. Just now I said root, left, right, isn't it? So after the D, we will go to H. Left, Now, do you have right for D? No right. So if no right, we will go back to the... Go back to where?
E.
Go back to the right side of B, isn't it? Because just now your root is B. After that, you go to the left. Now you need to go to the right of B. And at the right here, the root will be E. Now you repeat the process. Start with the root E, and then go to the left, which is I. Go to the right, J. Now you have done the left subtree of A. So the next is you go to the right subtree of A, which is the root is C. Then go to the which one? F. After F? K. Because the root is F, the left subtree of this C is the root F, but after F we don't have left, right? So we will go to the right, which is K. Once the left hand side of C done, we will go to the right. The right here, the root is G. After G, no left. If no left, we will go to the right, which is L. So this is the sequence after we visit the tree by using the pre-order search. Okay, next one. Let's say you have the completely parenthesis expression. This parenthesis is referred to your bracket. When they say completely parenthesis means that every part, as long as you have the operation, you must put the bracket. So you see here, B plus C means you need to do the B plus C first. After that, you need to do the A minus B plus C, followed by D multiply E, and then F plus G, and then divide, then the last one only plus. So they'll ask you to draw a binary tree and then apply the pre-order search. So now we draw the tree first. Huh? What is the root? Followed by minus, divide, left of minus, right, left of plus, B, right, C. Okay, then go to the left of divide, multiply, right of divide, plus, left of multiply, D, and the right is E. Left of plus, F, right is G. Okay, now we have the binary tree here, and they ask you to do the pre-order search. What is the sequence? First one, plus, minus A, plus B, C, divide, multiply, D, E, plus F, G. All can do? Root, left, right, huh? Root, left, right. Okay, so we will keep on repeating the same thing until the end of the tree here. And this form is not only called as pre-order search, we will call this as a prefix. When they say prefix means they don't put any bracket. No bracket in the sequence here. Or any other term for the prefix, we can call it as a Polish form. Prefix or Polish form. If let's say this question, they give you the bracket and then you draw the tree, follow the bracket, no problem, right? And after your tree here, you can write the pre-order search or the prefix, follow the sequence of root, left, right. Now, what if given now is the prefix form? If they give you this prefix form, can you write back to the fully parentheses like this, and after that draw the tree? Can? How do we want to put all this in a bracket? Which one we need to do first? Without looking at this, if I only have this. We need to find where we have the operator followed by two. How do we call the B and C here? Operands. One operator followed by two operands. We will do that part first. So for this one, if you want to solve it, you need to do the plus BC first, followed by multiply DE, followed by plus FG. That is the sequence you need to do first if the bracket is not given. They give you this form, prefix form. So you write this one in the bracket first, meaning that you have plus minus A, B plus C, divide D multiply E, F plus G. So you write like this first. Then after that, you will find again the operator followed by two operands. Now the B plus C will be one operand, A is another operand. So you will do this part. One operator followed by two operands. This part, one operator followed by two operands. So we will write it as equal to plus A minus B plus C and then D multiply E divides F plus G. Put in a bracket like this. Okay, then after that you have one operator here. This is considered as one operand, the whole bracket, and the bracket at the back is another operand. That means you have one operator followed by two operands now. So finally we will have A minus B plus C bracket. The plus will be in the middle now, and then D multiply E divides F plus G. Then we get back the same with this. Now we look at the example for the prefix form. If they give you the prefix form, how do you want to do the bracket fully parenthesis, and also how to draw the tree? Any problem with this? No? Okay, example this one. Number is easier because number you can solve it first. No need to put in a bracket. Now, for example, they ask you to evaluate this. Meaning evaluate means they ask you to find the answer. What is the answer for this? Which part you need to do first? Huh? Which one do first? Class. Which one you want to do first? Which one is one operator followed by two operands? Plus 3, 4, right? Okay, so here is plus minus 2, 3 plus 4 is? Seven divides by 8. This one you need to do first. 8 multiply 6 is? 48, right? Now, in order to not confuse the 4 and 8 or 48, you can draw a circle to represent that this is one number. Because if you write it, the space is small, then you will misunderstood it as 4 and 8. So we better circle the 48 together. So remind yourself this is 48 instead of 4 and 8. And the last one, 5 plus 1 is 6. And then followed by what? Now we need to do the minus 2, 7, right? So if you do minus 2, 7, what is the answer? Yeah? Negative 5. Also the negative 2 plus 7. 2 minus 7 is negative 5. Huh? Divides 48. 48 divided by 6 is 8. Minus 5 plus 8. 3. Okay. So the answer for this you get 3. And can you put this in the fully parenthesis or not? Convert it to the bracket form. Okay. After that, draw the binary tree. Now, from here, can you draw the binary tree? Can, right? Root left, right, isn't it? Root So follow the plus first, followed by what is at the left? Minus. Then left first. Left is 2. Right is plus. Then 3, 4. Right? Then we come to the right. Divide. Left. Multiply. Plus. Five, 1. If like this, you can write the fully parenthesis already, right? Which one in the bracket first? Fully parenthesis 2 minus 3 plus 4, then bracket plus 8 multiply 6 divide 5 plus 1 bracket. You calculate, is it the same answer? Now, if let's say the question give you the prefix like this, right? It is not necessary you need to find the binary tree first, and then only you write the fully parenthesis. It is up to you which one you think is easier for you. If you think that you convert to the fully parenthesis is easier, then you do this first. Then only you draw the tree. If you cannot draw the tree from the prefix form, you can only draw the tree from this bracket form, and then you do the bracket first, then only draw the tree. The sequence doesn't matter as long as you can do all the answer. Understand that? Do you have any problem with this? Can follow that? Can I? Okay. So this one is for the first one, which is the pre-order search. You have root, left, right. Now we go to the second one. What is the sequence? Left, root, right. In order search. For the in order search, we will visit the left first, followed by the root, last one only the right. Okay, now look at this. Which one first? Which one is the left? From the tree here, which one is the left? A is the left, right? So we go to the A first. After that? Minus. After that?
B.
Left. This the whole thing of the tree here. The left subtree of the plus is this. So we must start from the left subtree first. And from the left subtree, we need to start from the left. And this is the root. Minus is the root, meaning that the A will be the left. Correct? And then, after you go to the left, you need to go to the root, which is minus. Once you have done the root, you need to come to the right. At the right here, you need to start from the left. So you need to start from B. Then go to the root. The root is plus, right? The right of plus is C. Okay. Once you have done the left subtree of plus, you need to go to the root. So the root of this is plus. Then only you come to the right subtree. At the right subtree here, the root is divide, and this is the left subtree. This is the right subtree. So you need to start from the left subtree, left hand side. What is the left hand side of the left subtree? D. Root multiply right E. Okay, so once you have done the left subtree, you go to the root, which is divide. Come to the right, start with the left, so you have F. Root plus, right? So this is in order search. So if you read this sentence, they tell you that the in-order search actually is the same with the fully parenthesis sequence. If you do it using the bracket, you will get the same sequence like this. But the in-order search is only remove the bracket. Okay? Now, last one is the post-order search. Since we already have root left, root right, so the last one should be left, right, root. Post-order search. Left first, followed by right, and then root. Okay. Use the same example. This one is using the example 7. Okay. Now we will try to write the post-order search. Left hand side is, this is the left subtree. This is the right subtree. At the left subtree, which one is the left? A. After the A, we need to go to the right, isn't it? So the right will be this one, right subtree. You need to start from the which side? Left. So after A, we will go to B. After B, you go to C. After C, you go to plus. After plus, you go to minus. So you have done with the left subtree. Now you need to go to the right, isn't it? Left, right, root. So you go to the right, start with the left, D, right, E, root, multiply. After you have done the left hand side, you go to right hand side. Start with left, which is F, right, G, root, plus. So once you have done left and right, you go to the root, divides, right? Now you have done the left and the right. Last one is plus. Don't forget your plus. So this is the post order search. Okay or not?
example part 做哪一个先 OK？ example part 做哪一个先 OK？
就是讲哪一个？这个 parenthesis 的还是？
这个
好像没有讲，
都可以。
Okay, we look at this. See whether you can follow the sequence or not just now. Here we visit by using the pre-order, right? The first one. Now, can you give me the in order? Start from where? H. In order is left root, right? Huh? After H, you go to the root D, then B. Because this is the left, finish the left, we go to the root B, then come to the right, start with I, root E, right, J. Okay, finish the left, go to root. What is the root now? A. Finish the root, go to right, start with Start with left, right? Do you have left?
No.
If not left, go to root. What is the root now? F. Then K. After the K, go to the root C. Finish the root, go to G and L. This is in order, huh? Pause order. Left first. H. D. I. J. E. B. K. F. L. G. C. Okay, so left, right, root. Left, right, root. All still with me? Okay? I hope nobody will lost. Now, the binary search tree, afterwards here, this one is the order you have gone through already, pre-order, in-order, and post-order. Then after that, you have one part which is the binary search tree. This one is we add in the items one by one, meaning that how do we want to put it in the binary search tree, follow the sequence given in the question. So this is the algorithm, but I will show you how to do it using this example. They say form a binary search tree from the words given here and using the alphabetical order. Now, I'm sure you know alphabetical order A to Z, right? So, the first word is mathematics. We put it as the root. After that, the second word is physics. When we put the binary search tree, we'll follow the order of the alphabet, meaning that you look at the first one, P, you need to compare with M. Physics come after or before mathematics? After, right? Because P is after M. So if this come after, we will put it at the right hand side. Add in here. Follow the alphabetical order. Physics after M, P, so put it at the right. And then geography. Left or right? Geography, G, come before M, right? So put it at the left, geography. After geography, zoology. So you need to put at the right or left? Right of what? Right of which word? when you want to insert the zoology, you need to start from mathematics again. Every time need to start from the root again. So if you compare the zoology with mathematics, you will go to right or left? Right, isn't it? Then, but at the right here, you already have physics, correct? So that means you need to compare one more time the zoology with physics. So the zoology should be at the right of physics. So we will add in here zoology at the right of physics. Meteorology, right of
physics.
Yeah, at the right of mathematics and the left of physics. And then geology, GEO. Start from mathematics, geology should be left or right? Left. Then you come to the geography, geology should be left or right? Left or right? Followed by psychology, PSY. PSY. Right of mathematics, come to physics, PSY is right or left? Right. Come to zoology, PSY is right or left? Left. And the last one, chemistry. Where should we insert the chemistry? Here, right? Okay. So we have done using the alphabetical order to construct a binary search tree for the words given here. So next time when they give you, when they ask you to do the binary search tree, you follow the sequence given in the question. Don't arrange the alphabet first. Okay? You don't go to arrange the chemistry, put at the first one, and then followed by the, which one? Geology. No need to arrange by yourself first. Just insert, follow the sequence given one by one. Now, under the binary search tree, if you look at this, you have another example, and after that, we need to calculate what is the expected number of comparison. Meaning that, because just now, when you insert every element, you need to compare, start from the root, isn't it? Right? Every time when you compare, start from the root, then you come to the right, you need to compare one more time with physics, and also the geography. So that means the number of comparison that we need to do is every level will increase exponentially. You see here, this one you will compare with one time. This one you need to compare how many times? 4 times, isn't it? Because you have 1 here, 2 here, 1 here, 2 here. So at the second level, you already need to compare for 4 times. Same also, if you have 4 elements at the third level, you need to compare how many times? 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. Total? Every element before you insert at this level here, you need to compare for 3 times 4, isn't it? Which is 12 times, right? So for this, when they ask to calculate this, expected number of comparison to locate an item, meaning that when you put in every item, how many times you need to compare, this is the expected number, which means the average number. So we need to calculate like this. 1 for the first element. This is the second level. So we need to compare with 2 times how many elements we have? 2 elements here, so we have 4 times for this level. For this one, third level, you have 4 elements. So every element you need to compare 3 times. So that's why you need to multiply with 4. And for the 4th level, you only have 1 here. If you compare, you only need to compare 4 times. 1, 2, 3, 4, right? So when you want to calculate the average number of comparison, you just total up all these. 1 plus 4 plus 12 plus 4, and then the average is divide by how many elements altogether. Here you have 1, 2, 3, 4, 5, 6, 7, 8. So you divide by 8. This is the number, expected number of comparison. Expected number of comparison. You calculate this, 21, right? So this is equal to 21 over 8. Average number of comparison you need to compare is this. Okay, now I tell you first for this example how to calculate this, so that in the example 12 you can calculate using the same method to find what is the expected number of comparison. For the example 12, this is involve the numbers. Just now this is the alphabet. So alphabet, which one comes first at the left? Which one comes after at the right? Same also if it is a number. Which number is smaller at the left? Which one is bigger at the right? Do the same like example 11 for example 12. Can you do that? Okay? Okay, do it now. Oh, you want to go back and do? I think some have class, right? Just now I said 15, now already. Left how many minutes? The group, you want to go first?
大的在左边啊。
I need to dismiss
大
now.
的在哪里啊？
Do I need to dismiss now? Yes. Then I have one group come is before the class. I have one group is after the class. So 15 plus 15, 30 minutes gone.
大的在哪里？大的在左还是右？
Huh?
大的在右，小的在左。
Can already have lunch. Good, good reason, no? So see how is our progress. Now the first lecture I still can follow. I can teach until here. So at least you can do your tutorial one. Okay, but you no need to rush the tutorial. You can do it slowly. We can 2 weeks to do the tutorial. We only have 7 tutorials. So don't tell me you don't have time to do one. You can do it in the class or you can do it before, up to you, as long as you do. So you try this one first, and next week I can let you check the answer. We do it also next week. Okay? All of you already take your attendance? Taken already? Don't tell me after this I forget to take.